So good afternoon, everyone. Thank you for joining my session. Uh, I'm just going to start with. I think I'm already sharing my screen. So I'm just going to start with autonomous vehicle and what is out there at present and where are we and what is going to be the future from here on. It's just going to be an overview of what is happening and where can we be in little bit of a time ahead. So let me start this session. Thank you again for joining. So these are the topics I've decided to cover. Initially, I thought I could just prepare a little bit of slide, 5 to 6, but when I started preparing it, it went to nearly 16 slides. So please bear with me. I'll complete it as fast as possible. So let's start with what is autonomous vehicle. So with the word autonomous, what we're going to do is we're going to replace the driver itself, and this system is going to replace a human, and it's going to do all the tasks which a human performs. So it is going to apply brake, increase speed. It's going to check the road signs, and it's going to drive automatically. So that is autonomous vehicle in a simple sentence. So we already have this concept. We got it in Tesla. Google is working towards it. We got Uber. Uh, they're trying to invest more on autonomous vehicle, and they're gonna bring in more on their side as well. So let's dive deep into it. Okay, so when I said we're gonna replace a human, there should be a system in place which performs all the tasks which a human performs in much more accurate and in much more sensible way, right? Without any errors or without making much of a collision. So we got a bunch of radars and stuff when it comes to autonomous vehicle. So we got LiDAR, and then we got uh, cameras all around the car, okay, to capture and to create a 3D map of what is happening around the car. So with the help of the onboard computer, uh, car itself would position its present state, and it could able to drive within that 3D map, detecting all the collision, applying brakes, and detecting all the road signs and stuff. Okay, that's about a little bit about the sensors that has been used for the autonomous vehicle. The main sensor that has been used is LiDAR. LiDAR, it's been widely used even for sensing, for remote sensing technology and stuff. It's nothing but a giant laser, which has been produce 1,000 pulse in a second, I believe. So it's uh, it's gonna be penetrated on an individual surface, or there's gonna be a target which the laser will be penetrated, and when it reflects back, they will capture it. And the advantage of lidar is when we gonna survey a land, say I'm surveying the earth from above, it could eliminate all the vegetations. Okay, I could able to get the bare earth without any vegetations in it. So LiDAR has been widely used in robotics and even in autonomous field. So next slide is about data processing. 1 minute. Data processing and interpretation. So all these sensors, it is going to create a 3D map. And once when a map has been created, we would need a lot of processings to be done with a lot of algorithms. There are complex and machine learning techniques. There are a lot of algorithms to detect, say, if I want to detect there is a collision ahead. If I want to detect that, there's an algorithm in place for that. So for machine learning to calibrate each and every sensor that has been attached on the car, there is an algorithm for that. So there are n number of algorithms which is going to govern each and every part of an autonomous car. Okay, that is being performed on each and every calculations and a minute. I mean, it had to act fast, right? It should not take a longer time to react. So it should make split-second decision about how to navigate the road ahead. So those kind of decisions will be done by the onboard computer. So I just want to give a glimpse of various algorithm that has been widely used. The first one is SLAM, which is simultaneous localization and mapping. So with this algorithm, the car vehicle itself could able to create a 3D map, and it could able to position itself in that map. And the rest of other algorithms are object detection and tracking, control system, sensor fusion, and even sensor calibration. So these are some algorithms which I could able to uh, grasp and share it to everyone. But there are still more using which vehicle itself can drive without any drivers. So I'm not gonna deep dive into each and every algorithm. I'm gonna leave it as such. So people are interested who could come back to this slide and check on it. So most of us would have already seen this kind of an image or a car with a lot of sensors on it. Okay, so if this is a picture of an autonomous vehicle, uh, probably a normal car with all the radars and all the mechanical stuffs attached to it. Okay, so in this picture, you could see it has got a radar in front and a lidar at the top, which is the primary sensor using which a 3D map can be created. And sorry, okay. So this is how the hardware connection would be. So the processor, because we have to make a decision in a split seconds, right? So the processor that has been widely used are from NVIDIA, Neosys, and GTX. These are powerful GPUs. In particular, Neosys, it could withstand vibrations and even some worst climatic conditions as well. It has been architectured and it has been manufactured in such a way that that's a suitable processor to have it on an autonomous vehicle. And Neosys has also been used on robotics and other technologies as well. So as for this hardware connection, we got car power system, and then this is where all the sensors would come into place. Okay, all the sensors would be connected to that onboard computer. And then we got GPS, Wi-Fi router for GPS. So the vehicle can be positioned where it is at present. And if someone else from, or there should be, I mean, someone else should be monitoring it, right? So for monitoring it and to give some input to that vehicle, we got mouse, keyboard, and most of the vehicle, they would also have a joystick kind of a thing to control the vehicle. So this is an overview of how the hardware connections would look like. Now let's move on to the software. So as per this diagram, the main part is to create the ST map and to localize the vehicle where it is at present. And with that HT map, with a lot of algorithms in place, we're gonna do a lot of predictions, planning, which will be in turn controlled. And we do have a guardian, which is nothing but a fail-safe system. Okay, one of the processor will be controlling and guarding each and every task that has been performed. If something goes wrong, it will jump into action. Say, it will apply the brake or some kind of an protection mechanism if something goes wrong. That is what the guardian does. And each and every devices are connected using CAN bus. This is one of the communication protocol which has been widely used in robotics as well as in autonomous vehicle. CAN, it stands for Controlled Area Network. So this is the internal software architecture. And if someone has to monitor, maybe a person who's sitting inside the car or someone else from a station, okay, from a permanent station, they can also monitor it. And HMI, it's nothing but human mission interface, wherein a human can interact with that vehicle or someone else directly from that monitor location can interact with the vehicle. This is the software overview. Just moving on to the next slide. So when it comes to autonomous vehicle, we do have two types of connectivities. One is vehicle to vehicle and the vehicle to interface. Vehicle to vehicle in communication is like one vehicle can communicate with another vehicle. Say there is a huge convoy where politicians usually go on a long, they usually go on multiple cars, right? And each and every car will move in a very close and tight spot. So in such a situation, V2V will come into place where one vehicle will communicate with another vehicle and it will share the data across. So using this communication, we could actually understand what happens, and each and every vehicle can travel in a much collision-free way. Okay, and the other one is V2I, vehicle to interface, wherein the interaction of the communication will be with a central hub. Say there is a traffic signal, okay, like signs on the road. So those kind of communication, it will be like if it is red, if it is going to be red in 2 or 3 blocks, vehicle will be informed prior. So vehicle would know that they're going to be a red signal. So it will make calculations. It will save fuel and apply brake. There won't be any sudden jerks or anything like that. So it's going to be a very smooth operation based on the patterns, traffic patterns, conditions, and potential hazards, and so on. So these are these are the two basic communications that has been followed right now with autonomous vehicle. And then the levels of autonomy. So the level Society of Automotive Engineers, it's one of the society which has been formed in US, and they have graded the autonomous vehicle based on different levels from 0 to 5, 0 being the lowest and 5 being the topmost autonomous vehicle. So the current vehicle, what we have, even the Tesla, it has been rated as level 2 autonomous vehicle. And even in India, we do have a lot of autonomous vehicle, right? Like XV500 and Hyundai Tucson, and even MGS, 1 or 2 vehicles with ADAS. They call it as ADAS function. It's not autonomous. ADAS means Advanced Driver Assistance System. That is different from this because autonomous aim is to replace the complete driver, but ADAS, it is something which is going to assist the driver. Okay, so these are two different things totally. They're going to provide a similar kind of a support, but the end point and the end result is different. Okay, with autonomous, we're going to take out the driver at all. I mean, we're going to take out the driver, and vehicle will take all the decisions, and it will directly deliver its passengers in their destination. But with ADAS, we're going to have an assistant for the driver. Say it will able to detect the collision ahead, and if there is any sudden interference, the car could able to brake itself with ADAS function. And then with level 2 ADAS function, on an highway, it goes adaptive cruise control, and then sign detection, speed detection. Vehicle can itself lower its speed based on the signs on that highway. So all these kind of detections are in place with ADAS function. So coming to autonomous, as I said, even Tesla, it is operating at present of level 2. So level 3 and level 4, it's in testing right now. So anything above that is level 5, something a vehicle can run without any human intervention at all. So we don't have a successful commercially tested vehicle for the end users yet. It's still in testing. And now comes cybersecurity and concerns. So with autonomous vehicle, again, whatever technologies that we're going to bring in, there will be some risks and security concerns, right? So similar to that, to address, there are several concerns. Say a hacker would able to gain access to a vehicle system to take the control of your complete vehicle, and he could also cause accidents and stuff. So to avoid all these, companies are working on it. They are trying to encrypt and introduce a lot of firewalls into it to avoid all the risks and stuff. But it's still in process. They haven't come up with a proper solution yet. And next comes ethical dilemmas and liability issues. So again, all these cars, say a car, it drives on its own. If someone is going to sit inside that car and something happens, whom are we going to blame on? So that remains still a question, whether it's a driver, manufacturer, or the software developer. Okay, that is a question for which we don't have an answer yet. And apart from that, there are also ethical consideration like what a vehicle should prioritize at that time. For example, if there is a collision, whether vehicle itself, it has to take care of the passenger inside it or the person who's standing in front of him. So those kind of decisions are still complex issues which have to be considered and which have to be considered and come out with a solution. So that's still in pending. And then comes leading companies in autonomous vehicle department. As we know, we got Tesla, one of the leading company, and Uber and Google. A lot of other companies are working towards it, and they are planning to bring than the end user vehicle like cars. They are planning to bring in autonomous vehicles like truck, because trucks are something which can run 24/7, right? And they could match, or if there is no, they could take care of the supply 24/7 without any to say that, okay, without any supply demand, right? So if, for example, there is some restriction for a truck driver. You should not drive a vehicle for more than 8 hours or so. So with autonomous vehicle, if that's going to be an autonomous truck, then there won't be any restrictions at all. Okay, the things can be delivered at any time, and it can run 24/7 tirelessly. So that is something which can be achieved as well. So we are at the end, at the conclusion. So with autonomous vehicle, there could be reduced traffic congestion and improved safety and increased accessibility for the people who are unable to drive. And it could also add more to that environment by reducing emission and improved fuel efficiency. And as this technology continues to evolve and becomes more widespread, we can expect to even see greater benefits and advancement in the exciting field. So in this exciting field. So that's about the autonomous vehicle in short. I've also managed to share few links about open source autonomous projects out there. Apollo is one of the successful open source autonomous project. If someone has wanted to just get through and take a glimpse of it. So that's all. Thank you. Any questions?